Underwater volcano off the coast of California, and scientists think it could erupt soon.
It's more of a science gold mine than a danger.
We're about 150 meters above the lava lake.
And although scientists are certain that these volcanoes in our own backyard will erupt again, the question is, how soon?
From sunlit vineyards to legendary surf breaks, California is a land that dazzles on the surface. For decades, its fame has rested on golden coastlines, Hollywood legends, and the relentless promise of frontiers, physical, cultural, and technological. Beneath the everyday bustle of Silicon Valley, Hollywood, and the vast, wild stretches of the Sierra Nevada, however, another California has existed, quietly waiting to be unearthed. In recent months, a series of discoveries have challenged what we think we know about what really lies beneath the Golden State, from mineral-laden lakes that could hold fortunes beyond imagination, to the subtle yet unsettling peeling of the planet's crust, and the tremors from hidden volcanic forces below Pacific waves. California is rapidly rewriting its subterranean story. Today, we're plunging deep into the ground, the lakes, and the ocean floor, uncovering the shockwaves, both literal and figurative, that have caught the scientific world's attention. These aren't the headline droughts or wildfires you might expect. Instead, you'll hear about immense mineral discoveries, lands that slip silently into the sea, and volcanic giants lingering beneath the surface. So, before you grab your hiking boots or hit Highway 1, settle in. Because after what scientists have just found, lurking underneath California, you may never look at this state in quite the same way again. The big question: if California has always promised gold above ground, what is it really hiding beneath? The gleam of white gold, the Salton Sea's $540 billion secret. Tucked away in Southern California's shimmering desert, the Salton Sea is not the kind of place most associate with riches. Born from a mishap in 1905, when the Colorado River broke through an irrigation canal and flooded the basin for nearly 2 years, this saline inland sea has weathered a strange history. Once a glitzy mid-century resort getaway, then an ecological cautionary tale of drying shorelines and toxic dust, it seemed destined to quietly evaporate from public consciousness. And yet, beneath its silvery waters and sulfuric vapors, a 21st century treasure lay hidden, one of the largest lithium reserves on the planet, with a projected market value of more than $540 billion. The scale of the find is staggering. Geological surveys estimate that over 18 million tons of lithium, often dubbed white gold, are dissolved in geothermal brines beneath the Salton Sea. In today's energy economy, where lithium-ion batteries power everything from electric vehicles to smartphones and grid-scale storage, such a reserve is nothing short of a strategic jackpot. But how did this happen here, of all places? The story reaches deep into California's geologic past. The Salton Trough is part of an active rift zone where the North American and Pacific tectonic plates grind against each other, creating geothermal activity and fault-driven hot springs. Over millions of years, volcanic eruptions, mineral-rich ash deposits, and weathered rock contributed to a unique mineral stew. As hot water circulated through these volcanic and sedimentary layers, it leached lithium and other critical elements into deep brine aquifers, gradually concentrating them beneath the desert floor. This isn't just a geologic curiosity, it's an energy opportunity. With demand for lithium expected to quadruple by 2035, the Salton Sea could reposition California as a global energy leader. U.S. policymakers have already signaled growing interest, framing the region as Lithium Valley, a domestic answer to foreign-controlled lithium sources in South America, China, and Australia. However, the rush to extract brings serious environmental and ethical questions. The Imperial and Coachella Valleys are home to vulnerable populations that already suffer from high asthma rates, water scarcity, and poverty. How will lithium extraction affect air and water quality? Can new geothermal lithium technologies minimize harm, or will the process deepen existing inequalities? Current pilot projects aim to extract lithium without traditional mining, using closed-loop geothermal systems that generate electricity while filtering lithium from brine. If successful, this could offer a model of green extraction, reducing environmental costs and providing local jobs. But the stakes are high. Industry players like GM, Berkshire Hathaway, and even federal agencies are watching closely, aware that failure or mismanagement could turn the region into a symbol of broken promises. For now, the lithium remains sealed beneath layers of brine, heat, and history. But with each well drilled and each permit granted, the Salton Sea inches closer to becoming a focal point of the global energy future. Whether it becomes a story of regeneration or exploitation depends not just on geology, but on the decisions we make now. Earth peels. Beneath the Sierras, a tectonic mystery unfolds. To most, the Sierra Nevada is simply California's granite backbone, a recreational mecca, a region of legendary natural beauty. Towering peaks, glacial lakes, and alpine forests draw millions each year. But few realize that beneath this serene facade, a profound transformation is underway. In 2025, a growing body of seismic data and deep Earth imaging pointed towards something truly extraordinary. A portion of Earth's lower crust is peeling away beneath the Sierra Nevada. This phenomenon, known as delamination, is not theoretical. It's a rare but well-documented geologic process where dense, cold rock at the base of the crust detaches and begins to sink into the hotter, ductile mantle. In response, buoyant, molten material from deeper within the Earth rises up to fill the void. The result is not only a structural reshuffling of the continent's foundation, but a powerful mechanism for driving mountain uplift, volcanic activity, and even long-term changes in surface geology. In the Sierra Nevada, scientists began to suspect delamination after analyzing patterns in seismic wave travel times, gravitational anomalies, and mantle tomography. Certain seismic waves traveled faster or slower through the region than expected, suggesting variations in density, denser, colder remnants of lower crust falling, and lighter material rising in response. Further confirmation came from geochemical signatures in young volcanic rocks east of the range, which bear isotopic clues indicating recent interaction with mantle-derived magmas. What's even more remarkable is that this process may already be reshaping the Sierra Nevada. Uplift rates in certain zones have accelerated over the last few million years. Subtle but measurable movements that suggest the range is still growing, even as erosion wears it down from above. Some researchers believe delamination is a key factor behind this ongoing elevation gain. The process also reorients tectonic stresses, potentially reactivating ancient faults or influencing the region's complex seismic behavior. Although delamination itself unfolds over millions of years, its cumulative impacts on earthquakes, crustal deformation, and volcanic systems are real. Some even speculate that parts of California's interior volcanic fields, like the Long Valley caldera and Mono Inyo craters, may owe their origins to past episodes of delamination. For the average person hiking the Sierra's granite trails, the transformation remains invisible. But geologists now see the Sierra Nevada not as a finished monument of the past, but as a living, evolving system shaped by unseen forces deep below. This discovery adds a new dimension to our understanding of California's geologic instability. It raises urgent questions. Could future delamination events trigger new volcanic episodes? How might these changes influence groundwater systems, fault zones, or even long-term climate feedbacks? The Earth beneath the Sierra Nevada is shifting, not suddenly, but inevitably. And in that slow-motion upheaval lies a reminder that even the oldest mountains are still writing their story. A volcanic giant awakens. The Pacific's unpredictable threat. California sits on the volatile edge of the Pacific Ring of Fire, where tectonic forces generate earthquakes and volcanic eruptions around the basin's rim. The state's most visible volcanoes, Mount Shasta, and Lassen Peak are reminders of this legacy. Yet recent attention has shifted offshore, where scientists have identified a highly active undersea volcano near California's coast, a feature previously overlooked beneath the deep Pacific waters. This volcano, first flagged by unusual seismic tremors detected on ocean bottom seismometers, has since revealed its restless nature through an array of instruments. Hydroacoustic sensors, specialized devices that detect sound waves traveling through water, have picked up repetitive bursts consistent with submarine volcanic venting. Plumes of mineral-rich water, laced with sulfur and silica, have been observed rising from fissures near the volcano's summit, hinting at activity deep within its magma chambers. What surprised researchers wasn't just the existence of this volcano, but its apparent level of activity. In recent years, sonar mapping and ROV surveys have confirmed fresh lava flows, warm hydrothermal vents, and even small collapses along its flanks, suggesting internal pressure buildup. Though no full eruption has been confirmed, scientists are growing increasingly convinced that this undersea giant is awake and evolving. Underwater volcanoes present a unique challenge to geologists. Unlike land-based systems, they are difficult to monitor continuously, and eruptions often go unnoticed unless they generate surface disturbances. Yet their risks are real. A sudden, violent undersea eruption could displace massive volumes of water, potentially generating a localized tsunami. Even absent an eruption, the release of gas, particularly CO2 and methane, can alter ocean chemistry and impact marine ecosystems. Beyond physical hazards, such volcanoes can also influence regional ocean currents, fish migration patterns, and nutrient cycles. Some hydrothermal vents become hotspots for rare marine life, ecosystems fueled not by sunlight, but by chemical energy. Thus, this volcano might not only represent a geologic risk, but also a site of biological significance. The volcano's proximity to fault lines along the continental shelf raises further questions. Could seismic events on land trigger changes beneath the sea, or vice versa? Are there more such active seamounts lurking undiscovered along the California coast? For now, emergency planners are keeping watch, supported by NOAA and the USGS, who continue deploying seafloor monitors and refining oceanic hazard models. While there are no current warnings, the situation underscores a broader reality. California's greatest geological threats may not always come from above. It's what lies beneath that could surprise us next. Sinking land, rising dread, California coastlines at risk. California is known for its spectacular coastline, beaches, cliffs, and neighborhoods seemingly impervious to change. But this tranquil scene conceals a quieter, more insidious threat. Land along several sections of the California coast is slowly sinking, even as global sea levels continue to rise. Armed with sensitive satellite-based INSAR radar systems, long-term GPS arrays, and tide gauge comparisons, scientists have now confirmed that subsidence, the downward settling or compaction of the ground, is actively occurring along both urban and rural stretches of the coast. What's alarming is the dual exposure. As the land sinks, the sea rises, creating a compound threat for coastal communities. What's more, some of the state's critical assets, ports, airports, and industrial zones, sit in low-lying coastal areas vulnerable to these combined forces. Legacy pollution, buried in old landfills, or sealed under industrial sites, could be disturbed as shifting groundwater tables change the chemistry of subsurface environments. In extreme cases, areas that once drained efficiently may find themselves permanently waterlogged or below future sea level projections, forcing the construction of seawalls, pumps, or even managed retreat strategies. The threat is not uniform. Some coastal regions are stable or even slightly uplifting due to tectonic uplift, but the patchwork of sinking, rising, and steady terrain complicates statewide planning. That's why scientists are urging integrated climate resilience models, tools that combine sea level projections, subsidence rates, rainfall forecasts, and socioeconomic data to guide smarter development and infrastructure investment. California's coast is not just changing, it's sinking and shifting, often in places people least expect. What appears stable today may prove vulnerable tomorrow. Understanding and adapting to these hidden movements is now a central part of protecting California's future in a changing climate. The hidden cost of treasure, mining, toxic legacies, and ecological peril. Lithium's promise as the backbone of new clean energy technology is shadowed by concerns about how it is extracted and managed. The image of $540 billion in lithium under the Salton Sea is compelling, but the realities of mining raise challenging questions. Extracting lithium from the brines beneath the Salton Sea involves pumping up mineral-laden water and processing it to separate the valuable element. Although touted as less environmentally damaging than hard rock mining, this technique is not risk-free. The potential exists for contamination from toxic byproducts or accidental spills. The region already bears scars from earlier waves of industry. Agriculture and other enterprises have left behind traces of arsenic, pesticides, and metals in the soil and water. Communities in the Imperial and Coachella valleys, often low income and predominantly communities of color, are vigilant about new industrial development. Concerns are not merely hypothetical. Wind-borne dust from the shrinking Salton Sea already causes significant public health challenges, and new infrastructure could exacerbate those risks. Local advocates and scientists urge that any lithium extraction must be paired with careful environmental monitoring, robust safety protocols, and meaningful local involvement in decision-making. Companies are exploring ways to minimize waste and water use, but the potential for unforeseen consequences is real. The region's ecological stability, community health, and the legacy of environmental justice are in the balance. Can this white gold rush become a model for responsible clean energy development, or does it risk repeating the mistakes of earlier extractive booms? Earthquakes and ominous signals, the peeling planet scenario. For Californians, earthquakes are an expected hazard, but recent discoveries beneath the Sierra Nevada point to a different kind of geologic change, one that may amplify or alter earthquake patterns in ways scientists are only beginning to understand. Seismic studies reveal that a process is underway in which the dense, lower crust is peeling away and sinking. This ongoing separation and descent of deep rock could foster new earthquake clusters by redistributing stresses in the crust. It may also relate to shifts in regional uplift, influencing the height of mountain ranges and the layout of earthquake-prone zones. Unlike shallow faults that can be visually mapped, these deeper processes are tracked through indirect evidence. The speed of seismic waves, subtle subsidence, and rare, deep tremors. The unpredictability of such deeply rooted events means they are less well understood, yet they could shape the risk profile for the entire state. Scientists emphasize that while these findings are significant, they do not suggest a sudden increase in major earthquake risk, but rather a long-term need to refine our understanding of how California's landscape is evolving from the deepest mantle to the surface. The volcano beneath the waves, a ticking time bomb off the California coast. The discovery of a highly active undersea volcano has added to scientists' concerns about geologic hazards. Remote sensors indicate growing unrest, clusters of undersea quakes, eruptions of superheated water and mineral-rich plumes, and shifting underwater formations. While no immediate evidence signals an impending major eruption, and there is no confirmed timeline for any catastrophic event, the potential effects of an undersea eruption, however rare, are serious. Such an event could, in theory, disturb shipping routes, impact marine life, and, in some circumstances, generate local tsunamis. However, scientists caution that predicting eruptions is an imprecise science, especially for submarine volcanoes that are hard to observe directly. Maritime agencies and researchers continue to monitor seismic and acoustic data around known volcano locations. For now, these hazards remain mostly theoretical for the public, but they represent another facet of California's complex and ever-changing relationship with the geology beneath and around it. A state in flux, questions without answers. So, when you peel away the fame, the fortune, and the stories Californians tell themselves, what is left? A land in flux, a state built on movement, gold rushes, tectonic shifts, and reinvention. But now, facing profound changes, not just at the surface, but deep below. The recent scientific discoveries only sharpen that sense. The next big fortune may lie not in technology or entertainment, but in the mineral-rich brines under a dying sea. Mountainous landscapes may rest on a crust in slow-motion transformation. Even the foundations of beloved beaches and coastal towns prove far less permanent than people imagine. With each seismic echo beneath the Sierra, every plume above an undersea volcano, and every exploratory drill below the Salton Sea, the story of California becomes more complex and perhaps more urgent. As choices are made about resource extraction, housing, infrastructure, and risk, Californians and the world must balance hope with caution, opportunity with stewardship. Will the state and its communities benefit from these new riches without repeating old mistakes? Can it defend its shores and valleys while confronting challenges that originate miles beneath their feet? Or are we only beginning to realize how temporary our grip on this dramatic landscape really is? Now, it's your turn. Which of these revelations struck you most? The buried vault beneath the Salton Sea, the peeling roots of the Sierra, the volcanic mysteries offshore, or the beaches slowly sinking below the Pacific? Share your thoughts and keep questioning, because sometimes the most consequential discoveries are those we can't yet see, hidden just beneath our feet, shaping the future one layer at a time. Until next time, stay curious and keep seeking what lies below.